So in this video, let's understand our pointers. Very important concept. I'm saying it. Okay, we will be requiring it everywhere. Every now and then we'll be using this. Okay, so that's why I'm covering this topic. So the concept that we'll be covering is pointers. Okay, let's understand what this is. So before understanding, let's actually run a small program. Okay, and then understand pointers in detail. Okay, so let's first create it a file. So let me write this part. Code iostream using namespace std int main. Okay, let me write one thing. Okay, and I'll tell you what I'm writing. Very simple. I equal to I plus 1 and just see out the value of I. What should I get? Obviously 11, right? So 11 is getting printed. Okay, so someone can someone tell me? I'm doing it. Okay, int I equal to 10. That's great. I was made, we know it, and i's value is 10. Okay, I wrote here I equal to I plus 1. How is the compiler knowing that, hey, what is the value of I? Okay, how is it knowing, and how it is gonna go and update the value? Okay, let's understand this line properly and carefully. So internally, what's happening at line 4 is, okay, at line 4, okay, it's an integer. Okay, then let's create a 4 bytes size memory. Okay, the name is I. Okay, whose value is 10. Okay, internally what actually happens is, and in the next line I'm coming and memory I equal to I plus 1. So how will system know that this is I? Okay, obviously in the memory it's not written I. Okay, so how will system know that this is the value? Okay, so in this line what actually happens is, there is something called a table. Okay, there will be a table where it's written that, hey, I is basically created at a given address. Okay, now how I can access it? I'll be like I plus 1, you're saying I plus 1, so let's go to address 750. Let's say this is kept at 750. Okay, then let's go to address 750, whatever the value is, add 1 to it. Okay, add 1 to it. So what is kept here? 10 is kept here, so 10 plus 1, 1. Okay, add to it and then again store there only. So this value gets updated by 1. Okay, making sense here? Simple, right? Okay, great. I hope this is clear. Very simple. Now one thing I'd like to tell you, since I can get the addresses, okay, so what's actually happening? If I'm gonna create int j, okay, and let's give the value as 7. So what will happen internally? J will be created. Okay, J will be created, but will be assigned with a specific address. We'll see. Okay, the address right now only. Let's say that address is 800. So in my table, this table, a value of J will be assigned. Hey, J is kept at 800. Okay, whose value is 7? Whose value is 7? So now if I want to print cout, if I'm doing cout J, okay, how will system know where is J? It will first go in this table and it will like, hey, is there something called J? Yes, there is something. Where is it kept? It is kept at 800. So go to that specific memory block and print whatever is kept here. So 7 will be printed here. Okay, that's fine. What's happening? So let's even print J. It's gonna be fine. Simple again. Simple enough. Okay, so let's create J whose value is 7, and we're just sorting the value of J. Okay, without doing anything. Okay, so obviously what should be printed? 11 and 7. So wait a second, what's here? This is sign semicolon, right? Okay, so we should expect 11 and 7. Okay, it's taking some time. Okay, 7 and 11. Okay, great. That means what actually happening? What's actually happening internally? See here. First of all, integer block is created in the memory. Okay, who's is gonna create? It's actually created in the memory, so it's created at a specific address. Okay, so that's address value is kept in this table. Okay, and by the way, this table is actually known as your symbol table. Okay, symbol table. Okay, so just saying table is fine. Okay, so it's saying that, hey, this that says created at 700, address 700. So at 700, what is the content that's been kept? 10. Okay, so I'm like, okay, first add it and then again print it. So add 1 at the specific content and print it. So what's actually happening, see the points, first create the memory block, okay, second is assign it in the symbol table, third is whatever value it is you can put it in this specific memory. Okay, so now we can see that this has some address. So is there any way with which I can access the address of this specific block? Okay, I'm saying this is 700, but for assumption I'm taking 700. Actually it's not 700. Let's see what is the address. Okay, just for assuming it that it has some address, I took 700, but let's see what actual address is. Okay, so how will I know this? If I come here and instead of doing this, let's say, let's not do this. Okay, okay, if I do this ampersand I, that means I was giving me the content, but ampersand will tell me, hey, this is kept at this specific address. Okay, so let's see what is the address. The address is basically, okay, it's taking time, but it should just come. Zero x f6 ffE1c. Very complicated, right? It's given in hexadecimal. Okay, this is basically hexa because we can see from here. Okay, if this is 0x, that means it's in hexa. Okay, forget it about this. This is basically just an address. Okay, for us it's just an address. Okay, making sense? So what these pointers are? Pointers are basically, okay, actually pointers, okay, pointers are basically some variables, okay, which will store the addresses of a specific variable, of another variable I should say. Okay, so let's see the address of, see, we can store the integer values, right? So obviously there should be a way where we can store the addresses too. So they are basically known as pointers. Okay, making sense? How and what are pointers? Pointers are basically which are going to contain the addresses of specific or other variables. Okay, even they are variables, okay, and they will contain the addresses of other variables. Let's see how and what I'm saying. Let's see how they're first created. Let's say, see, who's, see, first of all something will be there and I want to put the address of I. Okay, I want to put the address of I. Okay, what is I is basically an integer, so integer type. For pointers we put a star. Okay, okay, right now just to differentiate we put a star. Okay, and then here I'll put the name of the pointer. Let's say p1 is the pointer. Okay, so what did I do here? I said, okay, I have created a pointer p1 who is keeping the address of I. Okay, if you want to get the proof, let's see how will you get the proof. Okay, so let's see out p1. Okay, so I'm printing the address of I and I'm printing whatever is kept at p1. So obviously they should be the same value, right? If it's containing the address, then they should have the same value. Okay, so let's see here, they'll give the same value. Okay, they are giving the same value. You can assume that obviously you will not be like, hey, my address is 6ff in when you are just dealing or just trying to do the dry run. So you can assume that there is a specific address like 700, 800. Okay, so right now what's happening, let's see. Right now things are getting a bit weird, not weird, but a block of I is created. Okay, I is created whose content is 10, and this I will be created at some address. Let's take that 700. So in my table, in order to actually go and print the value, to update the value, I need the address, right? So this address is basically kept at 700. Okay, my table. So if I want to make some changes, I'm like, okay, you want to make changes in I, so go to that specific address. So you come here and whatever you want to do, like I'm doing here I+1, so do the I+1. Okay, this is something that we need to do. So through line number 5, what happened? This became 11. Clear is fine. Okay, great. I'm printing it, fine, it's fine. At this line, I'm creating another variable which is a pointer variable. Okay, which is a pointer variable. So let's say that this is p1. P1 is containing the address of I. So what is the address of I? 700. Okay, it's containing 700. So obviously p1 is also a variable. Even it will be made in the memory, even it will be having some address. So in the system table, in a symbol table, even this will have its own address. Let's say it's made at 800. See, it's containing the address of this I. Okay, but even this has some its own address. Okay, so let's see what's its address. Okay, let's say we're assuming it's 800. Let's see what's the actual address. So if you come here and if you do here, like, how will you find the address? We have seen it. Just use the ampersand sign. Okay, so just use this ampersand and you'll get the address. So this line and this line will give me the address of I. This line will give me where P is actually made. Okay, so let's see here. Okay, it's taking some time, but okay, see, this was same, but this is different. Okay, saying that this is actually at a different address. Necessarily, it's not necessary that it's gonna come. It will be like after I P will be created. No, okay, it can be created anywhere in the memory. Okay, making sense? Okay, great. One thing I would like to tell you, if I make a change out here, let's make a change. Okay, let me just clear this part. I think this part is clear, right? So let me clear this part. Okay, let me clear actually this part. If I'm doing something like this, if I'm doing something like this, let's not print the address. Obviously, we know that they are printing the same address, right? So let's not print the address right now. Okay, so let's see out these values. Let's see. I'm actually going and making here. Like let's say I'm doing here. I'm not doing I plus 1 here. I'm doing here I plus 1 here. Okay, I'm printing the value here. See out I. Okay, so I will be before it's 10, right? Afterwards, I'm updating I equal to I plus 1. Okay, and afterwards, I'm like, okay, before that, we can obviously see out. This is gonna be. So what do we expect? Obviously, here 10 and here 11, right? Simple, very simple, right? Okay, no problem with this. What if I wanted to do this? See here. Even through the help of pointers, we can actually access the values. How we'll access it? Let's see. I'm writing here, hey, P is basically the address of 700. Okay, in order to print the value, okay, I'll put here a star symbol again. This star symbol is basically dereferencing. Okay, dereference used for dereferencing. It means that go to that specific location that that you have kept the address of and get this value. Okay, and print it. Let's see what I'm saying. Let's see what I'm saying. Okay, I know it won't make sense like this. Let's just print it. So instead of printing I, let's just, okay, let's not do this as of now because I want to show you the difference right now. So out here, let's do cout star P. See here, I have given here a pointer. Okay, this is basically the syntax. Okay, after you have given the syntax, if you write here cout P1, okay, it means that this is basically the address. Okay, if you're giving a star in front of it, it means that go to that specific address and print the value. Making sense? I hope it's making sense. So let's run it and see. This line will give me the address and this line will give me the value. Okay, so let's not print this, or even we can print this, even I here. So if you see properly what we're getting, firstly, this value is basically printed due to this line number 5. This value is getting printed due to line number 9, and this value 10 is going and getting printed through line number 10. So star P1, what did you understand? Let's see. Star P1 means if you are putting star, that means you are going to go to that specific address. That means you have kept 700. So where is 700 pointing to? 700 is basically pointing to this. Okay, and you went to that address and you are actually printing that value. Okay, why can I do this? Because what's actually happening is, okay, let me just clear this part. Okay, let me just clear this part. Okay, if you see properly, the value of I is basically known only to the table. Okay, so if I want to make a change, like even if I want to print a value cout I will go to the simple table and I'll like, hey, where is I created? It's created at address 700. So go to that 700 and print the value. Now even P1 has the address of I. So it's like, hey, what is the address of I? It's 700. Go to the address. So how do we go to the address? By using the star pointer. Okay, star symbol. So go to that address and print whatever is kept here. Okay, star means go there. Where you need to go? To the specific address where P1 is pointing. P1 has the content. P1 has the content of as 700. So go to 700 and star means print that value that is kept at 700. That's the reason we were getting here 10. Okay, great. Then can I do this? You're gonna see an interesting thing right now. Okay, you'll be seeing a very interesting thing right now. Okay, great. So what I'll do, I'll be like, okay, it's fine if you can print it, that's really great. Can I do this? Obviously, yes. What will be the value here? Anyone? I value will be basically increased by 1. Whatever is the value. Value is basically 10. So I could increase by 1. Can I do this? Star P1 equal to star P1 plus 1. And let's print Cout. Cout. This is going to be interesting. Cout after P1 increased. Okay, let's just understand what I'm going to do. So what is someone expecting? What are we expecting? First of all, here I1 will be increased, so obviously here I can get 11. What is this line doing? Okay, let's understand this line. Okay, so let me print and then I can also show it to you what does this line exactly mean. Okay, so let's just print the value first. Obviously it will be increased even from that star P also. Let's see how we'll do it. Okay, so I should give a gap. Actually I haven't given a gap. Let me give a gap, because if I am not giving a gap, it's, let me give here a gap. But I'm not giving a gap. Everywhere handle is here, and I is getting printed. Should I give a gap here? Handle is here. Okay, fine, it's fine. Okay, that's here. This basically after 10 we're not giving a gap. Where are we putting this 10? Okay, here, that's the issue. We need to give a gap. Okay, now it will be fine. Now what's happening here? See properly. Let's understand this properly. Okay, this is gonna be interesting. 10, okay, great. It got printed due to this line. I can agree to it. P1, okay, it was printed due to this line. Great. 10 was printed due to this line. Okay, we saw that through star we can actually access the values. Okay, so I went here and through the star I actually printed whatever was here. Okay, right now it's 10. Okay, right now it's 10 because I have not increased till now. Okay, here I have increased the value, so I increased it by 1, so it became 11. Afterward I have printed the value 5. Okay, great, it's I is 10, 11 now. I is obviously is 11 now. I came here and I'm doing star P equals to star P plus 1. What does this mean? It means that, hey, we know that this is the value of star P1. That means you went, see, star P1 basically means you went to this address and you're trying to access whatever is kept here. But now you're not accessing, you're not actually showing it to the user. You're actually, what you're doing, you went and you're like, okay, whatever is kept at this star P1, see, P1 is basically the address, which is 700. So, right, obviously it's kept made 700. Star P1 is doing, if I will see out the value P, then it will show me the address, the content of P1. If I do star P, then it will go to the specific value and show me this content what is kept here. If I'm doing star P equal to star P plus 1, it means that, hey, star P, okay, go to that star P. Okay, star P means go to this specific location 700. Okay, what is kept there? 11 is kept there. Increase this, see, 11 is kept there, right? So whatever is kept here, 11 is kept here, add 1 to it, add 1 to it. Okay, and actually show the changes in star P only. Star P means basically this address only, right? Star P means this specific 700 only. Okay, making sense? Is this making sense to you guys or not? I'll explain again. See, I value till here it's fine, right? Till here it's fine, I guess, that we are getting I equal to 11, right? I will increase the value of I. So internally what actually happened, I want to increase I value. So what is I kept? I is kept at 700, let's say. So go to this specific address, go to this specific address. Okay, I went to this specific address. What is kept here initially is 10. Increase that value by 1. Okay, see, go to the specific address what is to be done? Whatever is kept in I. So what is kept? 10 is kept. Add that 1 with it and put that specific value in I again. So again putting the value here, so it will become 11. Making sense? Similarly, this P also has the address of I, right? So let's say P is kept at 800, but P, this is P, okay, it has the 700. 700 means I'm saying, hey, star P means star P plus 1, okay? Go to this star P basically means go to this address, okay? You went to this address, put one more value there, that means now it's 11. See, I'm talking about the same address, okay? I'm talking about the same address because star P also has the same address as I, so go to the same address, increase the value by 1 through this line number 13, increase the value by 1 and put the value in P1 again. So star P1 value is basically 11 right now, okay? So you do star P1 equal to, what is star P1? 11, okay, 11 plus 1. So if you see properly, star P's value is updated by 1. That's the reason we are seeing this 12 here, okay? Understanding what's happening? So I changed my value. I can change the value not only by using I but by even using P, okay? We got a huge power. That means, see, it means that you have a specific address, okay? You have your friend's house there, and two of you know the address of the specific friend's house, okay? So he went there and he did some mischievous things. Obviously even he can go and do the same thing, right? Let's say here he has kept some chips with him, and he went and he actually, see, both of them have the same address, right? So he went and he took the chips. Next time if he goes the chips, if you go to the same address, obviously you won't find the chips, right? Because he has already taken this part, has already taken. So similarly, in order to go to this I, firstly I had only one way to go, okay, through this symbol table, okay? So in this symbol table I knew that I is made at 700, so go to 700 and you can do subtract, add, whatever you want to do, you can do it. But now as soon as I created this P1, okay, I'm saying that, okay, whatever is this 700, I made it. So first of all put that value in 700. So now you have two ways. You can even go through this way, you can even go through this way, okay? So to go through this pointers way, you just need to use star. Star means you go to this address and then you, whatever is the content, update it. What are you doing? Star P means I am at this specific location right now. What I should do, I need to actually put star P plus 1. So star P1 means basically what is kept there. What is kept there? 11 is kept here right now. Add 1. Okay, I'm gonna add 1. It's 12. Great. So where should I update it? In star P1. So star P was basically pointing to this. So update the value here. Okay, I hope till it's clear, right? This is just the basic, right? Just to understand internally how pointers actually work. Okay, making sense? Yeah, I hope this is making sense, right? So these were just some of the things that I need to actually explain. In the next videos again we'll see some more interesting. This is just the basic, okay? This is just the basic, okay? In the next things, next video let's see some more stuff like this, okay? So but I hope you understood what did we think here. Firstly, we saw some important things. What is this? First of all, this line is basically break into two parts. First of all, there's something called a symbol table where the address of this has been kept. Let's say it's 700. That means it is created at address 700, okay, whose value is 10 right now. I created one more pointer. I'm saying, okay, you take the address. I have given address of I, right? Okay, great. I have one more who is created at 800, let's say. So since even this is a variable, so in the symbol table again I will get this value as P1 is created at 800. Okay, great. Now through this line I can see, through this line what I'm saying, hey, what is P1? What is the value of P1? So inside of P1, what is the value? 700. Star P1 means, hey, whatever is the content of P1, star means go to that specific address, because we know pointers actually contains the address. So star P means go to that specific address. Okay, go to the specific address I'm pointing here and see out the values. See out means whatever is kept now at this. So what is kept? 10. So that's why we're getting 10 here. I made I equal to I plus 1. So I plus 1 means I, through the system, through the table of the system, I went, hey, you want to do I plus 1? Okay, great. You go and just make I plus 1. That means you can make it 11. There is no issue with this. And I'm just printing the value. Now here is an issue. What is the issue? I'm like, okay, star P1 basically means this part. You go to that specific value and make star P plus 1. So make it one more, increase it one more. See, both the values are same now. Okay, even from here also I can get it, even from here. So as soon as I'm printing here I basically means this value only, okay, this value only. So what will happen? I'm printing here I, I'm like, okay, where's I? I will be getting access to this simple tables. A simple table will be like, okay, I is kept at 700. Go to 700, and now you like, now at 700 actually 12 is kept. So that's the reason we were getting 12. And see here again, if I print it again using star p1, star p1 will be like, okay, hey, what is p1? P1 is 700. So star means you need to actually dereference it. That means go to that specific address. So you'll be like, okay, let me go to the specific address. Okay, what is kept? 12 is kept. So even here also we'll be getting 12. Okay, let me show it to you. I'll be like, even if I come and print here, let's see, printing I, printing p1. If I want to print here star p1, then the changes will be reflected even here, because even this is pointing to the same address. Star p1 means go to that specific I and show what's the value. I've already increased using using this I and using this also. Okay, so obviously we're gonna get the value as 12 12. Okay, so let's see. Okay, let's see, we are getting here, I'm printing through I, and here I'm printing through p1, and both the values are same because they are pointing to the same address. Somehow things are clear, right? Somehow I think things are clear. Okay, so in the next videos let's do some more things like this. Okay, so see you guys here. Okay, thank you.